With secondary active transport, we still require energy, but that energy in the form of ATP is used indirectly. And what we mean by saying that ATP is used indirectly is that we must have primary active transport first. So without primary active transport occurring, we're not going to be able to get secondary active transport. So we're going to draw out an example of how primary and secondary active transport work together. So for primary active transport, we already know an example of how this occurs, and that is with the sodium-potassium pump. So I will make a simplified sketch version of the sodium-potassium pump over here. So as you can see, over here we have primary active transport because ATP is used directly. This ATP is necessary because it loses its phosphate and releases a great deal of energy, and that happens to be enough energy to pull in potassium against the concentration gradient and push out sodium against its concentration gradient. Over here, for secondary active transport, I have a more ovally shape. This is the sodium glucose co-transporter. Also, a protein. So we have our protein over here is a sodium-potassium pump, but our protein over here is a sodium-glucose co-transporter. What that means, co-transport, co means together, is we're pulling sodium and glucose into the cell together. So with this, sodium moves back into the cell, and because we forced it out here using energy, it's going to already want to come back in. So now our sodium is moving down its gradient. And that's a great thing, because when sodium moves through this sodium glucose co-transporter, guess what else moves across it? If you guessed the sugar glucose, you would be correct. So in the long run, by doing this, we're saving ourselves ATP, because with one molecule of glucose, we can get upwards of 20 molecules of ATP. And we only had to use one in order to bring it in. And one very important thing to note here is that the sodium-potassium pump required a molecule of ATP. because it is primary active transport. The sodium glucose cotransporter did not require ATP. But the cotransporter did rely on sodium gradient. Remember, sodium is that Na+. Created by the sodium-potassium pump. And because of this reliance, we say that this is secondary active transport.